In our video on Booleans and conditionals, we learned how to use if and else to make decisions in Python. This structure allows our program to choose between two paths, one if the condition is true, and one if it's false. But the if-else structure we've built has some limitations. It only gives us two possible paths, and it only allows us to test one condition. Let's see how to move past those limits, starting with how to handle more than two possibilities. Let's go back to our example program that recommends what to wear based on the temperature. At the moment, the program first checks if the temperature is below 50. If the answer is yes, it prints, "Wear a jacket." Otherwise, the program prints, "No jacket needed." This works, but it only handles two scenarios, cold or not cold. What if we want a third option? For example, suppose temperatures between 50 and 65 count as mild, and we want our program to suggest bring a light layer in this situation. With the current structure, there's no place for this middle option. Thankfully, Python provides another key word, Elif, when we want to consider multiple alternatives. This keyword is short for else if, which gives us a clue about how it works. Like the else statement, an elif statement is executed only if the condition in the if statement is false. And, like an if statement, an elif statement is executed only if the condition that follows it is true. This means that if our program evaluates the elif condition during execution, it must be the case that is cold is false. In other words, it must be that the temperature is 50 or above. So, to determine if the weather is mild, we only need to check if the temperature is below 65 degrees. Then, just like with if and else, we end the line with a colon. Indented underneath the elif statement, we write the print statement that will run when the condition is true, bring a light layer. Great! To see how this new structure works, let's do a few code traces. For our first code trace, we'll set the temperature to 55. When Python arrives at the if statement, it checks the value of is cold. Since 55 is greater than 50, is cold is false. So, Python skips the code indented under the if block and moves to the elif block. Here, Python tests whether 55 is less than 65, which is true. Because the statement is true, Python then executes the code in the elif block and prints the message. Finally, since the elif condition was satisfied, Python skips the else block entirely and executes the end of the program message. Running the code, this is indeed the output we get. Great! Now suppose it cools down and the temperature drops to 40. When Python executes the if statement, it checks whether is cold is true. Since it is, Python will run the if block and print wear a jacket. Because the if condition was true, Python skips both the elif and else block that follows. This means that, even though 40 is also less than 65, the elif block is not run. The condition is not even tested. Running the code with the temperature at 40, we get wear a jacket as expected. For the final scenario, suppose the temperature warms up to 75 degrees. In this case, Python first checks the if condition and sees that is cold is false. As a result, it moves to the elif statement and tests the associated condition. Since 75 is not less than 65, this condition is also false. Since none of the conditions are true, Python executes the else block and prints no jacket needed. Running the code, that's exactly what we get. Great! Let's quickly summarize the three general rules that Python follows when executing an if, elif, else block. First, Python evaluates the conditions from top to bottom. Second, Python executes the first statement whose condition is true, or the else statement if no conditions are true. And third, Python skips all the statements after the first statement with a true condition. Okay, our if, elif, else structure now handles 3 possibilities. But we can take this even further. While we're limited to 1 if and 1 else per conditional block, we can chain together as many elif statements as we want. For example, we might want more possibilities for cooler temperatures to handle a chilly 40 degrees differently than a freezing 20 degrees. And for warmer temperatures, we might want different advice for a mild 70 degrees than a scorching 95 degrees. To handle these additional cases, we can add more elif blocks. Now we have 4 conditions plus a fallback. Even though we've added more conditions, Python still evaluates them from top to bottom and stops at the first true condition. Awesome! Now our program can handle as many scenarios as we need. But each condition tests only one thing: temperature. In practice, we might want our program to consider other criteria besides just the temperature when recommending what to wear. For example, whether or not it's raining could be important. To explore how to use multiple decision criteria at once, let's start with a new cell. Since we want to work with temperature and rain, let's create 2 variables to represent these states. For the time being, we'll set temperature to 45 and is raining to true. Then, let's say we want to recommend wearing something warm and waterproof if it's cold and rainy. In Python, to test whether 2 conditions are true at the same time, we join them with the AND keyword. In code, when we write temperature less than 50 and is raining, we're combining these 2 separate conditions into a single expression. This kind of expression is called a logical expression. A logical expression connects 2 individual conditions using a logical operator, in this case, AND. When the AND operator is used to connect the conditions, the logical expression evaluates to true only when both conditions are true. In this example, the temperature is 45, which is less than 50. So the left condition is true. And is raining is true. So the right condition is also true. So when Python evaluates the logical expression as a whole, we get true. But suppose it stops raining, so is raining switches to false. This means the right condition in the logical expression becomes false. So when we run the cell, the logical expression evaluates to false. Since AND logical expressions are true only when both conditions are true, every other combination of conditions evaluates to false. Great! Now that we know how AND works, let's use this logical expression in an if statement to determine what to wear. If it's both cold and raining, let's have our program print, "Wear a warm rain jacket." Outside the conditional block, let's signal the end of the program with a print statement. Beautiful! Since the temperature is below 50 and it's raining, when we run the code, Python prints the rain jacket recommendation and the end of the program statement. But if either condition is false, the AND logical expression will evaluate to false, and we'll only get the end of the program statement. Note that, just as we did before, we could add an else statement or even an elif statement to handle more cases. Great! The AND operator is useful when we want to require both conditions to be true for the logical expression to be true. But we don't always want to be that strict. Sometimes we want to run code if at least one of the conditions is true. For example, Suppose we want to flag whenever the temperature is extreme, either below 32 or above 95. In Python, we can test if at least one condition is true by using the OR keyword. To test out the OR keyword in code, let's add a new cell. In this cell, we create a temperature variable and set it to 28. We can then test this variable to determine if it's extreme by writing temperature less than 32 or temperature greater than 95. An OR logical expression like this evaluates to true when at least one side is true. With the temperature at 28, the left side is true. That alone is enough to make the logical expression as a whole true. Only when both sides are false does an OR logical expression evaluate to false. For example, if we set the temperature to 70, both sides will be false. This means that the OR logical expression also evaluates to false. Great! Like the AND logical expression earlier, we can use this OR logical expression as the condition in an if statement. If the temperature is extreme, we'll print a warning. Outside the conditional, we'll signal the end of the program with a print statement. Running the code with a non-extreme temperature, we get no warnings as expected. But when the temperature is extreme, we get our weather warning. Awesome! With the OR and AND logical operators, we can check multiple conditions at the same time. These operators let us handle lots of scenarios, but there's still something we currently cannot do: test whether something is false. For example, we might want to know whether it's not sunny, not cold, or not raining. To check whether something is not true in Python, we use the not operator. The not operator works differently from AND and OR. Instead of combining two conditions, it simply flips the value of a Boolean. Let's go back to our code to see how this works. Suppose we want to know whether an is raining variable is false. To check whether the variable is false, we write not is raining. In this case, since is raining is false, the not operator flips the value to true. But if is raining was true, not is raining would be false. We can also combine not with the and OR operators we learned earlier. For example, suppose we want to know if it's warm and not raining, a good day to go outside. To do this, let's add a temperature variable set to 75. Then we can use this variable to check if it's warm, above 70, and not raining. In this logical expression, Python evaluates the condition, temperature greater than 70, and gets true. Then it evaluates not is raining. Since is raining is true, not is raining is false. Finally, Python evaluates true and false, which is false. And just like with and OR on their own, we can use this combined expression as the condition in an if statement to execute specific code based on its result. Alright, we've done a lot in this video, so let's wrap up with a quick summary. We started with Elif to give our programs more than two possible paths. By chaining multiple elif statements together, we can handle as many scenarios as we need. Then, we used and OR to combine multiple conditions into a single expression. Finally, we used not to flip a condition's value, which we can mix with and OR for even more control. With these tools, our programs can make much more flexible decisions. Now, if some of this felt tricky, that's completely normal. Conditionals and logical expressions take practice to get comfortable with. If you want to practice what you've learned, we have exercises linked in the description. We're working on lots more Python explainer videos like this one, so be sure to subscribe so that you don't miss out. If you have any questions or topics that you'd like to learn about, Let us know in the comments below. We'd love to hear from you. Thanks for watching!